present topic on Introduction to Deep Learning and Neural Network, under which we are going to cover today the different aspects of deep learning and neural network. What are the different areas that are associated with deep learning and neural networks? We'll see the different types of models that are available in deep learning and neural networks. Later, due to the short span, we'll just see implementation of one of the model, that is the convolutional neural network. This is the most widely used model for image analysis nowadays in deep learning. So we'll see implementation of it using Python in Colab. And then we'll see the general trend, that is their current trends in, we'll have a short introduction about the current trends in deep learning that is going on in today's world, right? So let us start this session. When we talk about deep learning, machine learning, there are few more terms that come along with deep learning, and one of which is known as the artificial intelligence. Other term being the machine learning, then deep learning and data science. These are the four terms that are nowadays used most widely, right? And they come somehow with one another, right? So we'll see each of the term which is mentioned over here, and we'll try to find out the relationship between these terms, right? So what is artificial intelligence? So let us consider a Venn diagram, and in this artificial intelligence is placed over here, wherein through artificial intelligence we basically develop some applications which are called as the artificial intelligence applications, right? And the aim of artificial intelligence is to make machine work in a way that we human do, right? So the ultimate aim of artificial intelligence is to make machine as intelligent as humans, right? There are different applications of AI, like we see Netflix, we see YouTube, we also see the autonomous cars nowadays, the Grammarly software that we use. All these are nothing but applications of artificial intelligence, wherein we use certain algorithms, certain methods that are part of artificial intelligence. Like in Netflix and YouTube, we use the recommendation system, which is part of machine learning or deep learning, right? So artificial intelligence not itself is an artificial intelligence, but it also needs help of the other domain like the ML, DL, and for its implementation. So it is mixture of all, right? So now let us talk about the another term, that is machine learning, right? So machine learning is nothing but, in this Venn diagram, if I want to place machine learning, it would be a subset of artificial intelligence, and it would be represented like this. And the most important task in a machine learning application, or the most important thing to devise any machine learning application, is nothing but the data. So data is very much important for working of any ML application. This data is used, this with the help of machine learning and different mathematical and statistical tools which are available in machine learning. We analyze this data in order to predict, forecast information from this data. And in the way, we also pre-process the data, wherein we try to find the useful information from the data. We remove the information which is not of any use, or we just add some information which was earlier missing. So these are different tasks that are performed under ML. This ML it basically use the statistical tools which are provided in it, and by statistical tool I mean the mathematical formulas that are there in machine learning, which are used to make machine learn from the given data, right? So there are different types of machine learning. You might have gone through this in some of the earlier sessions, but I will shortly cover it. And the different types of machine learning techniques are the supervised learning, unsupervised learning, and semi-supervised learning. These are the three basic learning technologies that are used in machine learning. So let us discuss about supervised learning. Supervised learning basically performs two different types of functions, that is classifications and regression. In case of supervised learning, we have the data. As we have seen, machine learning deals with data. So here the data which is provided in supervised learning is called as the labeled data. Now why it is called as labeled data? Because along with certain inputs, we provide a desired output for these input data. Like consider these are set of images of dogs, right? So along these images, this is the input data. We also provide an output related to this data. That means it says that these are dogs, right? So for the input it is providing a respective output, right? So therefore it is called as a label data. This label data is now fed into our model in order to make our model learn, right? So whenever it sees image of this, it would learn that these are dogs. Same in the way that we started learning to talk. Our parents told that this is orange, so we multiple times they told that this fruit, this particular fruit is orange. Ultimately we were able to learn that yeah, these are oranges, and this is what we are doing over here. Supervised means there is a label data which is used to by the model to make decisions, right? Now, after the model is trained, the model is learned, we process different inputs and check whether the model is performing well or not. So, in processing, if we give certain images as input, here I have two images, one of the dog and another of a sparrow. So, if these two images are given as input to the trained model, it would output properly whether these are whether the input is dog or not. So this says that this particular image is a dog, and this says that this is not a dog, right? So as I have mentioned only about the dogs, not about the other part in the input data, right? So this is how your uh, supervised learning work. Let us consider another example of a label data. Now, suppose there are certain employees, they have some specific age, and according to age, this table is showing a salary that they receive at that particular age. So, if the age of the employee is 32, then he receives a salary. He or she might receive a salary of 40,000. At the age of 41, receives a salary of 60,000. So according to the age, the salary is changing, right? There will be multiple data available in it, right? So now what we do, we provide this label data to our machine learning model, make it learn from this data, and then when our model is ready, what we do, we give any random age as input to our data, and then for that age, the trained machine learning model will produce an output that is nothing but a salary. Okay. So for the input age, it would provide the respective salary and it would be accurate data. Now, as this age is determining the output that is salary, so this in input that is the age is called as the independent variable, whereas the output which is salary is called as the dependent variable, right? So this with the help of independent variable, we try to find out the value of dependent variable. Now, there are two tasks associated which are performed in supervised learning. The first being the classification. When we talk about classification, generally the output of classification is categorical. Categorical means we have two or multiple types. If we are able to bifurcate the input in these categories, it is classification, right? Like suppose here in this particular label data, we have additional field which represents the gender of a particular person, either male or female. So there are two categories over here. Now, based on age and salary, we can determine whether the person is a male or female, right? So here, age and salary will become your independent variable, whereas the parameter that would be determined based on it would be your dependent variable, right? So if we are classifying based on these two parameters, whether the person is male or female, we are having only two categories. So such type of classification is called as binary classification, right? I hope I am able to make sense, right? So this is about binary classification. But now, because the output is only in two categories, right? Suppose there are multiple categories now. If I add one additional category as none in the gender, right? Suppose that then it becomes three categories. So you are dividing the group in three categories. So it will become multi-class classification, right? So first is binary classification, another is multi-class classification. There is one more type of classification which is also called as the multi-label classification. Multi-label means a particular input belongs to multiple category. Like suppose we consider novels. right? So there are different types of novels. Some novels can be a tragic novel, some can be historical novels, some can be romantic novels, and there are different categories of novel which are present, right? But if we consider any particular novel, the Juliet, suppose we consider the Juliet, then this Juliet novel, if you have multiple novels and you have to categorize this novel in the different categories, so this Juliet is basically a historical novel as well as a romantic novel, right? So it would be placed in two categories, right? So as it is placed in two categories, such type of, and there can be multiple novels which are romantic as well as tragic or historical and tragic. So there can be multiple classes in which a particular input can be categorized, and thus this type of classification is called as multi-label classification. The another aspect of or the another problem that can be solved using supervised learning is regression, also called as forecasting. Herein, the output is basically a continuous value. Like you forecast a weather, so the value output value would be a continuous value. It can range from 1 to 10, 1 to 50, any range in between 1 to 2, right? So the output basically is continuous in case of regression or forecasting. The another type of learning which is there is unsupervised learning, and the basic operations which are performed here is clustering, segmentation, dimensionality reduction, right? So in ma'am, I hope I am audible.
Yes, sir, you are
Yeah,
audible.
yeah. And I hope it is going well. If you any participant have any doubt, they can interrupt me in between, right? So I can solve their queries also. Okay. So now unsupervised learning, it basically deals with unlabeled data. Unlabeled means we don't know what is the output for a particular input. There is no training data set. Now, if there is an input, so this is a random data which is given as input, raw data. Here you can find some images of dog. Here we find some images of cat. Now, these are some cats, some dogs, but the data is unlabeled. We don't know which particular image is of a cat, which particular image is of a dog, right? And our model also does not know. So what our model do? Our model use certain algorithm and try to identify some features from this set of images and then try to cluster them into a group of images which are having similar kind of features, right? So based on this, it use the algorithm train itself without any labeled data. Therefore, it is unlabeled data. It tries to identify similar patterns among different input and group them together. After that, after processing this set of input, identifying the similar features, it groups them into two parts. It segregates the dog parts separately and the cat parts separately, right? So it basically do clustering. This is called as clustering. Another task is segmentation, wherein we divide our input in certain segments, right? So similarly here, if I am a company wherein I want to organize tours, I am generally organize tour travel company, right? I organize tours. So now suppose I want to send information about the next tour which is being organized, such that number of participants who would participating in the tour should increase. For that, suppose I have a unlabeled data, right? So what I would do, I know this is the information about data, but I want to find which person I should be able to send the information to, right? So suppose I have age data, I have salary data, and I have the tours data, wherein this tour indicates the number of times particular person is visiting some particular or attending some particular tours, right? So what I can do, I can categorize this based on we can cluster this set of information into different clusters, wherein suppose I can divide them in three different clusters, and based on their salary, based on their age and number of tours they are attending, right? So here if I cluster them, I can find that these are the set of people who are generally visiting or having tours very frequently, right? So now, instead of sending the mail to these people multiple times, what I would do, I would send mail to this particular set of people so that I would get more response, right? So in this way, I can use unsupervised learning for clustering and use this for improving my business, right? The next type of learning is the semi-supervised learning. In case of semi-supervised learning, as the term itself indicates, semi-supervised means it is neither supervised nor unsupervised, right? It is in between something. So what is semi-supervised learning? In case of semi-supervised learning, what we have the input wherein some data or very few amount of data of the input is labeled data, whereas most of the part, that is most of the data in that input is unlabeled data. So here I have bifurcated the earlier image in two parts. These are the dogs, three dogs, and I have identified an input. This is labeled. So if these are the images, they are dogs. These are the three images of cats. So these are cats. So this is the input, and there is the desired output, right? Whereas these are unlabeled data. The remaining data from that data set is now placed over here. This is unlabeled data. What I will do in case of supervised learning, I will first train my model based on the labeled data, right? So I use the label data, which is a few amount of data, in order to train, in order to make my model learn, right? After this model is trained, what I would do, I would use the unlabeled data on this trained model and process it. So once I process this data, this unlabeled data, based on the trained model from the labeled data, I would get an output such that some of these elements would be placed as dog and the remaining elements of this would be placed as cats. So I would get bifurcation. Now these labels that are obtained after processing the unlabeled data using the trained model may have some error, like some cats might have been placed in dogs, some dogs might have been placed in cats, right? But I don't know. There might not be, right? So but this is now labeled data, which is obtained from the unlabeled data. Now, what I would do, I would use this labeled data and the existing data which was present over there in order to train a new model. So I will perform retraining based on this data. So I would use this data. So I have added this data over here for the dogs and for the cats also. So this label data and the existing label data which was given, I use both the data to retrain my model, right? And then again, I can use the retrain model for processing. So if earlier this model was predicting 95% accuracy, this might predict with 93% accuracy. But now I have utilized all the data, right? So it is anyhow improving the effectiveness of my data set, right? Instead of leaving the most part of the data and using few parts, I am using complete data in order to train my model, right? So this concept is called as a semi-supervised learning, right? Now let us come back to our uh, original Venn diagram. Wherein now the next concept is of deep learning, right? So deep learning is placed inside machine learning in this Venn diagram. That means deep learning is again a subset of machine learning, right? And this deep learning, it mostly deals with the neural networks. And the ultimate aim of developing deep learning or neural network is was to mimic the human brain. The scientists thought how our human beings, as we are considered to be the most intelligent creature in this particular world. So the scientists thought that how we can uh, use this intelligence and provide it to machine, right? So the ultimate aim of devising neural network was to mimic the human brain such that the machine would be able to learn in the way the human beings learns, right? And with the development of AI, we have already seen that machines are performing better than humans, at least in various strategic games. We have already seen that some of the machines or some of the artificial intelligence systems have already defeated humans in different games, right? So in deep learning, also we have the concepts of supervised and unsupervised and semi-supervised learning, right? So there are different models that come under the supervised and unsupervised category in deep learning also. We'll see what are the models. So in case of supervised learning models, we have artificial neural network, which is also called as the multi-layer perceptron. We have convolutional neural network and the recurrent neural network. We'll see when we can use this model. Uh, right, and another type of models are the unsupervised models, and in this we have self-organizing maps, the Boltzmann machine, and the autoencoders. So when to use these models? When you have a tabular data wherein the values are present in rows and column pattern, at that time we should use an artificial neural network, right? So it can be a CSV file also. Basically, whenever tabular data is there, you can prefer using artificial neural network. Whenever there is a problem of classification and regression related to real values and data sets are having real values, we should prefer artificial neural network. Whenever the model is required to have high flexibility, we prefer to use artificial neural network, right? Then the convolutional neural network, whenever the input data is an image, a two-dimensional data, we prefer convolutional neural network, right? Whenever the input data is two-dimensional data, we use convolutional neural network, but this two-dimensional data then can be converted to one-dimensional data internally in order for easy and efficient processing, right? And then the model which needs high complex calculation, at that time also we prefer to use convolutional neural network. There are different models of recurrent neural network, and these recurrent neural networks is basically used to perform analysis over the text data, the time series, or the sequential data. We prefer to use recurrent neural networks whenever there is input is text data, or time series data, or sequential data. Basically, it is used in natural language processing tasks. We also use recurrent neural network when we have to deal with image or video classification. Whenever we want to find the caption of a particular image or video just by looking at the context of the image or video, provide auto captioning, we make use of recurrent neural network. In sentiment analysis, basically all tasks of natural language processing, we make use of recurrent neural network, right? Most of the tasks of natural language processing, we use recurrent neural network. There are different models of recurrent neural network that you can study, uh, that are the RNN, the LSTM, the BERT, GPT-2, GPT-3. Will come we'll discuss about GPT-3 when we discuss about the trends in deep learning, right? When can we use the unsupervised models then? So whenever the data set does not have output, at that time we use the unsupervised model, the self-organizing map. It may be Boltzmann machine, it may be autoencoders. If the data set does not have the output parameter, we use unsupervised models. Whenever we have to create projects, creative projects like developing auto music, whenever you have to generate auto video from, like suppose there are music available nowadays, these systems are also the trending things in deep learning. Automatic music creation, automatic composition using the system. So you have different size, you have different sounds available, and you want to produce a new sound, you just provide the existing data to the deep neural networks, and then it would process it and produce a new music which would be unique. Obviously the machine is producing it, it won't be existing anywhere. So the projects wherein we have to create auto music, auto video generation, such type of projects, we make use of the unsupervised models. And obviously for dimensionality reduction, we use the unsupervised model for feature detection. Similarly, the Boltzmann machine model and the autoencoders are also used for dimensionality reduction. Uh, Whenever we want to build a recommendation system, we use Boltzmann machine or autoencoders. Autoencoders basically used for building more powerful recommendation system as compared to that of Boltzmann model. And then whenever we want to encode a particular data set, we have massive data set and we want to encode the different features, encoding features in massive data set, we make use of autoencoders, right? So these are the different models that are under supervised and unsupervised categories of deep learning. Due to the time constraint, we would be just specifically targeting the convolutional neural network, wherein we'll go into details of convolutional neural network, how it works, and we'll also see implementation of it before going to the trends in deep learning neural networks. Right. So what is convolution? The first part when we talk about the convolutional neural network is what is convolution. So convolution is nothing but the operations uh, which are used to process or create with the steps which are used for creating a feature maps from the input data, and then after it we applies a particular function to filter map it. Like now suppose there is an image of size 6 by 6 pixels. So this image is represented by some values, so 000 and 111. So this is white and this is black. So this is complete white part, this is complete black part of the image, suppose, right? So now we have to convolve it. So for this what we'll do, we have to analyze this image. So we'll not analyze the complete image at once, but we'll analyze some part of it, and for that we'll convolve it. We'll use convolution to analyze small parts of the image and try to identify the different patterns which are available over there, for which we make use of filters. So here a 3 by 3 filter I'm using, and there are different types of filters. These filters are basically used to extract the feature information from the input image. These features can be different types of features, and there can be hundreds and thousands of features that can be extracted. Right. So I'm using one filter over here. So it would be expecting one particular feature. And this particular filter which I have shown, it is a vertical filter. Now, vertical filter is basically used to identify the vertical boundaries in the image, right? Vertical edges which are present in the images. Similarly, if I transpose this, then it is horizontal features. And there are many more features that are sorry, filters which are available, the curve features, the eyes. There are different filters. Some filters can be used to identify eyes in the image, some filters can be used to identify nose in the image. There are different filters, and these are just assume that it may work like that. Okay, so when we use this vertical feature, what we do, we just put it on this image in this 3 by 3 size and try to identify, we try to convolve, we obtain the image as output. So how this we get an output of size 4 by 4, right? So how this after convolution, how this is obtained? So for that purpose, what we do multiplication, summation of the multiplication. What we do, we put this filter on the first part of the image, so it would be covering the 3 by 3 part of the image, right? So and then what we do summation of the multiplication. Okay, so if we put it over here, we'll multiply the respective values and do summation of all the values and put that value over here, right? So if I put it over here, so it would be 0 into 1 plus 0 into 0 plus 0 into minus 1. The second part would be plus 0 into 2 plus 0 into 0 plus 0 into minus 2 plus 0 into 1 plus 0 into 0 plus 0 into minus 1. The overall computation of this would be 0. So this value will be placed over here first, right? Then we move this filter one step to the right, and when we move only one pixel to the right, it is called a stride value is 1 over here. So we are moving, making a stride by 1 unit. So we are moving one step ahead. It can be 2 units, it can be 3 units. The number of pixels we are moving to the right is nothing but this stride. So by default, the stride for convolution is 1. Okay, again we put this filter over here in the new location, and again we perform the multiplication and summation. So this is 0 into 1 plus 0 into 0 plus 1 into minus 1 plus 0 into 2 plus 0 into 0 plus 1 into minus 2 plus 0 into 1 plus 0 into 0 plus 1 into minus 1. And the overall computation of this is minus 4. In the same way, we move right every time and perform computation and obtain the complete output uh, image, right? So here, this stride is horizontal as well as vertical. When we have covered all the horizontal pixel, we move to the one step to the down, and so in this way, we try to complete all the pixels that are available in the image, right? And ultimately, we end up finding an output of the size 4 by 4, right? Now, these values are this is the required output or the feature map of convolution. This can directly be used in the next step of convolution, that is max pooling, or rather you can apply min max scalar on this, and retransform it using the min-max scalar. In min-max scalar, what we do, we find the minimum value in this particular feature map and replace it with the highest value of the representation. Right here, we are talking about grayscale. The image is represented between 0 to 255. So 255 being the highest value, we will replace all the highest values. So in this image, -4 is the minimum value and 0 is the highest value. So we'll replace all the highest value with 255 and all the minimum value with 0. Right. So this is the retransformed image after applying min-max scalar. So this may or may not be applied, right? But now when you look at this convolution operation, you can find that the actual image was of size 6 by 6, whereas the output image is of size 4 by 4. So that means when we are transferring an image of 6 by 6 pixel to 4 by 4 pixel, there must be some loss of information, right? So if you want to avoid this loss of information, we can do padding. So before that, what we do, we have a formula for obtaining the size of the output when the size of input and filter is given. So the n represents the size of the input image, which is 6 over here, and f represents the size of filter, which is 3, and plus 1. So this will give you the size of the output. So this is 6 minus 3, that is 3, plus 1, that is 4. So it will be a 4 by 4 output, right? Now suppose you don't want that this loss should happen. What we can do, padding over here. Now padding means what? Suppose this is our 6 by 6 matrix, and we want that the output image should also be a 6 by 6 matrix. But you have seen that when we apply convolution directly to this image, it is reducing the size of the image to 4 by 4, right? So what we do here, we add an additional column after this. We add an additional column before the first column. We add a row above and we add a row below. So this addition of additional column and row or the pixels in the image is called as padding. Here we add only one column, one row below and at the end and at the start, top and bottom. Therefore, this is called as padding by 1. Right. Now, these values or these padded cells can be filled with the values either 0 or 1. Right. So you can fill this value by 0 or 1, or another way. So if you fill the value by 0, it is called as 0 padding. If you fill the value by 1, it is called as 1 padding. But there is another technique which uses the neighborhood values, the nearest neighborhood values, in order to fill this padded cells, right? So suppose this is the cell, the nearest value over here is 0, so it will fill 0. This is 0, this is 0. But here the nearest value is 1, so it would fill 1 over here, it would fill 1 over here. In this way, it fill the information, right? So these are the different types of padding that can be used, right? So once you have done padding, you can again apply the filter of the same size 3 by 3, and when you convolve it, the output will be output image of size 6 by 6, right? I have not done the calculation, but you can use the same technique for calculation and you can find the remaining calculations, right? uh, Now, in this way, this is a 6 by 6 output image, and the formula which we have for obtaining the size of the output image for a padded uh, input image is nothing but n plus 2p minus f plus 1, where n is nothing but the size of the actual input image, which is 6. 2p is nothing, p is nothing but the number of padding we have applied. So here p is 1, so it is 6 plus 2 minus f is nothing but the size of the filter, that is 3 plus 1, and ultimately you get the output as 6 plus 2 8 minus 3 5 plus 1 is 6. So you get an output of size 6 by 6. Now, once the convolution, so you can apply convolution directly to the given image, or you can apply it to the image after padding. Right. The next step in this convolutional neural network is max pooling. What we do, we first perform the convolution operation on the image. Suppose the image size was 4 by 4. We have applied a filter. Now filter size can be anything. Earlier we used 3 by 3. Here we have used 2 by 2 filter. Okay. And then we perform convolution and operation, and suppose this is the output. Now here your output is 3 by 3. So this is n, that is 4 minus 2 plus 1. So 4 minus 2 is 2 plus 1. So the output size is 3. Okay, I have randomly placed some value over here. Suppose after convolution we get these values at the output. So now what we do, we again apply the max pooling. So this max pooling enables the convolutional neural network to detect an image when it is presented with modification. Even the input is applied certain modification, either shift, right, can say invert, whatever modification is applied, it should not lose the data, but it should be able to perform this. So we apply max pooling over there. Again, we use max pooling layer. Suppose here we have considered the max pooling layer of size 2. So what we do, we consider this size of the max pooling layer, we apply it on this particular image and produce an output. So while doing this, what we do when we consider this particular part of the image, we we use the maximum value which is present in this particular region to be placed over here, right? So in this particular region, the maximum value was 4. So we are using the highest intensity, which is 4, right? Then here we move the window one step to the right, but here the minimum or the default stride size in case of max pooling is 2. So we move one step, 2 steps to the right. Right. So here the size of output is 3 by 3. So we'll skip the remaining part. We'll consider only these two, and the maximum value from these two pixels will be placed over here. That is 6. Similarly, we'll stride downwards again by 2. So this will be the highest value from 8 and 4. It is 8. And then again moving right. This is 2. So in this way, we apply max pooling, wherein we try to pick the maximum intensity value uh, with the help of max pooling. There are different types of pooling also. First is the min pooling, mi and min. That means we extract the minimum value from the pixel, and there is mean pooling, or we also call it as average pooling, wherein we identify the average value and place it over there, right? Then we will see implementation of this on the MNIST dataset. MNIST dataset is that we will be considering is basically uh, a dataset that consists of handwriting images of digits that are in grayscale, right? So when this dataset consists of around 60,000 plus 10,000, 70,000 sample data images, which are nothing but digit images, and they are also provided with label of this data. Label means for the training data set. Suppose the image is there. Suppose this image which is represented over here. This is 3. So the label of this data would be representing a digit 3, right? So along with image, we have also provided the data is also provided with its label, right? So this is the label data set. Therefore, supervised kind of learning. Okay. So the image that we will be using in this is will be of size 28 by 28 pixel. Okay, and then we would be using different convolutional layers, right? The thing that we have talked about convolution, now this convolution layer is now with max pooling can be stacked multiple times, and it can perform multiple operations in order to extract multiple features, right? So you can stack different multiple layers. Like here in this particular implementation, what we are going to do, we are going to use 3 convolutional layers over here and 3 max pooling layers. After that, we would be flattening the input. Now this input is flattened in order to provide it as an input to the dense layers, and then we'll use the dense layers to process it. So we'll see how this is performed. So we'll go through the implementation. So we'll basically work on MNIST dataset. As I've already mentioned that it consists of a grayscale image of handwriting digits and their correct labels from 0 to 9. So here what we'll do, we are basically going to use the Keras library, which is the most used deep learning framework, right? Keras is an open source API which is built on top of TensorFlow, and it minimizes the number of operations actions which are required, and it also provides the clear error messages, and it also has an extensive documentation which can be used for writing different codes, which would help us to write code, right? Now what we'll do, we'll first import our MNIST dataset from Keras, right? So this is a collab. I hope you earlier sessions you might have been made aware about collab. I'll directly show the implementation. You can also use any Python uh, IDE for executing it. You can use Jupyter Notebook also, right? So what we'll do, we'll use uh, from Keras, we'll import the dataset. So from keras.dataset, we would import MNIST. So when I execute it for the first time, it would be allocating a system to me. So it would take few minutes, a few seconds for doing so. And then later, when a system internally is allotted to me, would work efficiently. So it is connected now. I have allotted the system and now it is executing. So from keras.datasets, I have imported the dataset. Then what we'll do, we'll load the train images, the train labels, test images, and test labels over here, right? So here what we are doing now, we are loading the train images, the train labels, test images, and test labels. These are the different data fields which are available in the MNIST dataset, and we'll use the load data function on the MNIST to load this. So once it is loaded, you can see, yeah, it is loaded. And then what we'll do, we'll use this data set, the train data set, in order to make our model learn. And then we'll check the performance of our data set using the test data set, right? So the test images and the test labels we will be using to evaluate our model, right? So now let us see how our data set basically looks. So for that, we will see what is the type of image data which is available. So it is an image data. So we'll use train underscore images to see what is the type of this image. So you can see that it is a numpy array, right? Now, if this is a numpy array, what is the type of information or the data which is stored? What are the values? What are the type of values which are available in this data? So we'll see it train underscore images dot v type. So this v type parameter gives you the type of values which are present in this data set, and you can find that the d type data type of this particular set is unsigned integer, 8-bit integers, right? And this 8-bit integers is used to represent the different intensity levels between 0 to 255, wherein 0 represents the black and 255 represents the white intensity, white. And in between this 0 to 255, there are different gray shades. Okay, so 0 represents black and 255 represents white image, right? Then we can also see the dimensions of this train images. Train images dot ndim. So it will give you the dimension of the image. So you can see that the images of the train image dataset is of 3 dimension. And if you want to see the shape of this train images, then we have train images dot shape. Okay, so it would provide you with the shape, and it says that there are 60,000 rows information, 60,000 rows, and this 16,000 images are 28 by 28 size, right? So 28 by 28 pixel images, and total images are 60,000, right? Now let us see how we can visualize this. So before visualizing, I would also try to load in the similar fashion, you can check the size of your test images, and you can check the dimension of test images. So we'll just see what is the shape of test images. So it consists of, I think, 10,000 data fields, right? So this is 10,000 data fields. In the same way, now let us see how these images look. Right. So we'll use the matplotlib library in order to see how these images look, right? So we'll plot it onto the graph, for which we would be importing matplotlib dot pyplot as plt. Then we would use the imshow function, plt dot imshow, and apply it on train underscore images, and we'll see the first image. Second parameter is nothing, third parameter is nothing. We use scene as plt dot cm dot binary, right? And lastly, we'll use plot dot show, plt dot show. Okay, so here we would be looking at the second image in the data set, right? So I have put one over here, so it indicates the second image. The indexing is from 0, right? So 1 means the second image. So the second image represents 0 over here. Similarly, you can look 60,000 images are there. So suppose we want to see 16, right? So let us see the 16th image. So it is of 2, right? If you want to see 100, so let us see the 100th image. So it is something, right? So this is one of the reasons we'll discuss why there is no 100% accuracy in this. Okay, so what is this? Whether it is 5, whether it is, I don't know, right? So we cannot determine. Okay, so let us see the first itself. Similarly, you can find the output, or you can print the test images also in the same fashion, right? You can visualize these images using the different functions. Okay, so now let us look at the train labels also. Now, what are the dimensions of it, how we can use it, and whether this value is really labeled as 0 or not, because I am saying that this is 0, so if it is labeled as 0 or not. So let us first check the type of train labels. So that is, we have type, and we want type of train underscore labels. Okay, so the type of train label is again numpy array, right? And then if we want to check the shape of train labels, shape, so you can find that it is one dimensional. 60,000 values are there, so it indicates that as our 60,000 images are there, for these 60,000 images there are 60,000 representations, 60,000 labels. So for each image it is representing whether it is 0, 1, 2, 3 till 9, what value is it is having, right? So this is about label, right? So here we have seen the output of first image, which is 0. So let us check whether this image is really 0 or not. So for that, what we'll do, we'll call the train label, and we'll call the first value from it, as it is one dimensional array, only one over here. And you can see that it is 0. Now, the other value that we have used was 16, right? And 16 was representing 2. So if I put 16, so you can find that it is 2, right? We also have seen 100. So let us see what it was mentioning to 100. So yeah, according to this data set, that was 5, right? So you can see the label images also, the labels of these train images also, right? So now, in order to make sure that Keras is able to read our images and use them effectively, what we have to do, we have to reshape these images into one dimension instead of having the two-dimensional images. And for that, what we do, we multiply 28 by 25, 28, the size of the image, and we put these values, we set these values 28 by 28 into the interval between 0 to 1. And for that, what we'll do, we'll first transform it to uh, the interval between 0 and 1. So for that, let us first reshape our image. So I'll just, okay. So what I'll do, use the train images, and then the reshape function is used on the train images. That would be reshaping my data set into one-dimensional data. So I mentioned that it should be one dimensional. So it would multiply it and then train it. Then after reshaping it, what I'll do, I'll convert it to values between 0 and 1. As you have seen that the values which are mentioned over here in two-dimension images, they are the intensity values placed between 0 to 255. But now I want that it should be placed only between 0 to 1, right? So for that, what I would do, I would divide it with the highest value. So I converted it to float, and then I've divided it with 255. So I would get a value in between 0 to 1, right, on the trained images. Similarly, the same thing reshaping is I have applied onto the test images also, right? So if I do this, it has converted it to, it has reshaped the training and tested images into one-dimensional array, and also converted, scale down these values in between 0 to 1, right? Now the another transformation that I need to perform on the on this data set before training is to, should be converted or encoded as per the categories of the label, right? And this can be done efficiently and easily with the help of the Keras API, which provides a function that is two categorical method, and this can be used to one hot encode the integer data. And for that, we use the following code, that is from TensorFlow.keras dot utils. We'll import two categorical function, and then we use the train labels and convert it to categorical. And similarly for test labels also, we convert this to categorical. So categorical means it would convert in the categories from 0 to 9, as these were labels from 0 to 9, right? Then once this is done, what we have to do now, we have to build the TensorFlow, our CNN architecture, that is the convolutional neural network architecture, for which we have to import models and layers from Keras, right? So we'll import it from the Keras. So we'll use Keras again. We'll import models also, right? Now in this particular code, we would be using the sequential model. So our model will be simple sequential model, right? So we call model as equals to model dot sequential. And then we have seen in the presentation that here the image is a 28 by 28 size image, which is fed to the first convolutional layer of the two-dimensional matrix, wherein we have used 32 filters. So we use the convolutional layer. In this, we have used filters of size 3 by 3, and total we have stacked 32 filters, so that we'll be extracting 32 different information. Then this 32 different filter, the output of this is fed to 32 different max pooling layers. But now when we apply max pooling, when we apply convolution, the input image, which was of size 28 by 28, is reduced to 26 by 26. And there are 32 such images now, because we have used 32 different filters on this image, right? So we have 32 different images. Then we apply max pooling of size 2 by 2 on this. And when we apply max pooling of 2 by 2, the size of the image is halved. Okay. Uh, so the next in the next layer, after max pooling, we'll get the image size of 13 by 13, and again, as there were 32 features or 32 filters, we'll get these 32 different images, right? So this completes our first cycle, or the first layer of convolutional layer network. Okay, we can apply such multiple layers, right? So the first layer is okay, then we can use 2 layers, 3 layers, any number of layers. Here we will be using 3 convolutional layers. Okay, so this input will now given to convolutional neural network, okay, layer, and then it will perform convolution. But here what we'll do, we'll use the same filter size, but now we would increase the number of filters in order to extract more information from this image, right? So we'll use 64 filters, and the output of this after applying 3 by 3 would be 11 by 11, and there will be total 64 filters, so there will be 64 images, right? Then again we'll apply max pooling on it, and we'll reduce it from 11 by 11. Now it will become 5 by 5 by 64. Then again, this is second. We'll again apply the third convolutional layer, right? And we'll get again apply 64 filters, and we'll get an output. Okay, so this output will be 3 by 3 by 64, right? Then when we have to apply it, we have to the next dense layer, we have to flatten it. So let us see in this part how we build the neural network in our code, right? So here the first layer is added. So what we have done, we have first imported the model, which is our sequential model for our sequential data. And then what we have done, we have to add layers. So the first layer you have seen, it is the convolutional layer. So we use layers.conv2d. Number of filters which were used in first layer is 32, right? And the filter size, the filters that were used were 32, and the size of filter were 3 by 3, right? Here we use an activation function, that is value, and the input shape is 28 by 28 in one dimension. Okay, so this will create the first convolutional layer, and then after this feature mapping, what we do, we apply max pooling to it. So we add another layer for max pooling, and the size of max pooling was 2 by 2. We have understood this concept in the previous slide, right? So in this way, we have generated the first layer of the model, right? Now, this output of the first layer is fed to the next layer of the model, right? So we would just, I will just copy this, paste it over here. Now, instead of the input, now the input will be from the previous layer, right? So we would just use it as it is. And now, instead of this 32 filters, what I have done, I have used 64 filters, right? And then again, we would use the next layer, the same size for max pooling, and the third layer. So this I have made three different layers I have implemented, right? Now, once we are getting the output of the first three layer, what we have to do, we have to give this input to the dense layer. And for giving the input to the dense layer, we have to flatten the output, right? Flatten the output, which is 3 by 3 times of 64. So the image, last image that was of 3 by 3 size multiplied by 64, therefore there would be 576 something values present over there. Okay, so for this, what we do, the flattening. So we use model.add layers, that is flatten layer. It would convert the images into a sequence of data. Okay, and then we give this input, flattened input, to the next layer, that is the dense layer, wherein we use 64 values, and the activation function which is used is value, right? And then again, in the next layer, we use 10 layers, and the activation function that is used is softmax, right? And let us see, we'll print the summary of the model. So this has created our complete CNN architecture that we have studied in the presentation, and it would give the output. So here it shows what are the different layers. So the first layer was a convolutional layer, wherein the output size was 26 by 26, and there were total 32 filters which were used. Total 320 parameters were analyzed, and after applying max pooling, as we have seen over there, the output was 13 by 13, and again 32 filters were used. In the second convolutional layer, the output was of 11 by 11 size. This was the input over here, right? And there we used 64 filters. So this, and total parameters that were encountered were 18,496, and so on. So the third convolutional layer, and then the flattened, wherein we use 64 layers, the dense, and this input. Okay, so the total parameters that were studied is 60,554. Okay, so this is how we have created our architecture research. Okay, then the next step over here is to compile our model. And for compilation, we use the optimizer as RMS crop, and we use the following. And we just want to have only one matrix to evaluate the working of our model, that is accuracy. So we mention it over here. So we use model.compile. The optimizer that we will be using is RMS crop, loss function, and then matrix is accuracy. So we'll compile our model, right? Finally, what we will do, we we have made our model learn. We have to make our model learn, and for that we will be using the fit function, uh, and we need different arguments for it. So we give the train images, we give the train labels, we mention the epochs. Epochs are nothing but one epoch means the movement from one forward pass and one backward pass. That is one epoch. The movement from one forward pass to the complete one backward pass, it consists of one epoch. And in this particular layer, we are going to, in this particular network, we are going to use 5 epochs, right? Then there is a batch size. The next parameter which is given as is batch size. It is nothing but the number of training examples that would be considered in each forward pass. Whenever we are moving in a forward direction, how many examples will be considered for the training of data, right? The higher the size of the batch, the amount of memory that will be required will be more, right? So here we will be using a batch size of 64. So when we train our model using model.fit, it would work in 5 epochs. It would compute, it would train the model in 5 different epochs, and you would see that in after each epoch, the number of the accuracy of the model is improving, right? So it would take few minutes. So by the time this gets over, let us move back to our uh, presentation and continue over there. Right. So now here we have trained our model on the MNIST dataset. Uh, we have seen that MNIST dataset is basically a dataset that consists of digits, handwritten digits from 0 to 9, and there are total 60,000 to 70,000 samples over there, 60,000 in the training dataset and 10,000 in the test dataset. Now, this model gives an accuracy of 99 or 98, in between that 98, 99%, but it is not 100, it would be why? Because these images. Now, here, this image that we have to put this particular image in the label of this image should be either 3 or 8. What we should put, we are not sure, right? So this is an error. Similarly, the next image which is mentioned over here, whether we should place it as 9 or whether it should be a 4. So if such kind of data is given as input to the training model, it would be getting confused. And that's why we will want to get an accuracy of 100% over here. Right. So this was about the convolutional neural network. And again, moving back to our original start slide, that is the discussion between AI, ML, and deep learning and data science. So we have seen what deep learning is now. Now, the last part of it is data science. So, data science, where we have to place this data science. Now, this data science can be placed anywhere over here because it deals with the data science application deals with any aspect of either machine learning or deep learning or artificial intelligence. Thus, this data science should be placed in a particular location wherein it covers all the aspects. For making a data science application, you might be required to use the deep learning neural networks. You might be required to use the machine learning techniques for natural language processing and all, right? So we place this data science like this. It use technique of anything. So if you are a data scientist, you may be required to have a knowledge of machine learning. You might be required to have a knowledge of deep learning. You might be required to have knowledge of artificial intelligence, right? So all this is there. Data science is nothing but about extracting information from the huge amount of data with the help of the techniques and concepts that we have learned in artificial intelligence, machine learning, and deep learning, right? With some additional concepts also. Now let us move to the main concept, that is what are the current trends in deep learning, the main theme of today's uh, session. So deep learning basically is widely used in almost all industry or sectors of technology. One of it being the healthcare. Right? Deep learning has changed the healthcare sector or the healthcare industry by delivering new possibilities to improve the people's life. Right? It has helped for early detection of cancers from the images from the early stages of cancer and tumors with the help of images. Right? It has also improved the process of synthesizing new drugs. It has also made revolutions in medical imaging, wherein with the help of medical imaging or providing the input data of the medical image, our deep learning models can directly analyze the image and produce the report. Wherein now there is no need of doctors to read the report and write a particular analysis about what they have found in the images. It can directly be fed to uh, our deep learning models, and it would analyze the image and tell you whether you are suffering from a particular disease or not. So it has made revolution in the healthcare industry by providing such intelligent systems. I've also heard about use of iPhone for getting the image. There are applications wherein you can put the values or put a particular picture in an iPhone application with the help of iPhone image. This application is loaded onto the cloud, and then on cloud, the image is being analyzed by the deep learning system, uh, and you can get that whether you have what kind of disease that image is having, right? So this kind of system is available with the help of deep learning. Again, in entertainment industry also, deep learning is widely used for different purposes. Like we have already mentioned, the recommendation systems are widely used by different entertainment websites like the Netflix, the Amazons, YouTube. All these are making use of the recommendation system in order to provide a user with wide or user interface that would help user to find the best things of their choice, right, based on their interaction with the system, right. It has also been used. Deep learning is also helping in generating the auto highlights or the auto music generation, as I already discussed. What auto highlight here means, in 2018, in the Wimbledon tournament, the recordings were given or fed to deep learning neural networks, and this deep learning neural network analyzed the complete video of 3 hours and made a highlight based on the expression of the players. Right? So it has converted the 3 hours complete recording into a 15 minutes highlight, and this is done automatically. This is the trend which is going on in deep learning these days, right? So auto highlight generation or auto music generation. Another is we have already discussed this at the start. Again, like AI is helping to evolve the entertainment industries. Basically, in the gameplay itself, we have seen open AI that has developed um, that has developed a particular application in recent past, AI system, which defeated the world champion in the esports game for strategy development, wherein they have come up with OpenAI 5, and this OpenAI 5 used the concept of reinforcement learning for its training of the model, right? And this model was so efficiently trained that it was able to defeat a human expert in a particular game. And this was possible because the machines are now able to think beyond the level what you can think. While playing suppose chess, we can think only of the two steps ahead or three steps ahead of the person with whom you are playing, what he can be thinking. But these machines can move ahead of 10, 15, 20 steps ahead. They can vision these 20 steps ahead and what you can be thinking. All the possibilities are obtained in fraction of seconds. And with the help of that, it plays in a better way than we human being do. So this is again revolution in deep learning. Again, the earlier pictures, that is the black and white movies that were recorded, these are now being converted into coloring image with the help of deep learning. You can convert a black and white picture into a colored image, right? But just based on the context which is available over there along with it, right? Then again, sorry, uh, there are different service providers also, the cloud service providers or any different kind of service providers that are also making use of deep learning. Basically, the most important concept of deep learning is used in the improved natural language processing. The natural language processing, the solutions which are being provided in natural language analysis. Like for an example, OpenAI have released the latest version of GPT, that is GPT-3, which is nothing but a generative pre-trained transformer network, right? This is nothing but an auto-regressive language model, which can produce human-like text. This GPT-3 can also write stories, it can write codes, it can write scripts on its own. You just have to give a scenario as an input to this GPT-3 kind of a thing, and it would write a code. If you give an input that I want a code to be written in C++ for addition of two numbers, you just provide a scenario. This GPT-3 will convert it to a C++ code for you, or a C code, whatever language. This kind of revolution is happening. This is happening with the help of deep learning. This GPT-3, what I was talking about, is one of the largest neural network which is developed till date in terms of the number of parameters that it has used for training. It is being trained on 45 terabytes of data which are obtained from different sources. Right? Uh, the working of GPT-3 is based on what it takes in input as the sequence of words, and then it tries to predict what would be the next probable word, right? For that, it do so with the help of transformer neural network, right? Uh, Again, uh, this GPT-3 is different from that the existing LSTM and the RNN approach in a way that this earlier the LSTM and RNN were required to process the input data. Suppose we are talking about the sequence of data. It used to provide to process the sequence of data in the same sequence, one after the other. But in case of GPT-3 or the transformer network, it is not necessary. They can process the words simultaneously, parallelly, and they can use it in order to extract, by considering the semantic meaning, they can combine again, right? So this has helped in this improved natural language processing. Again, it is used for speech recognition, image classification, image captioning. There is again a new lipnet kind of thing, which is used to read the lip movement of a particular person. So if someone is deaf, just by lip movement, it is able to. If you have a mute audio system and you want to mute video, and you want to find the information or you want the audio for it, you can just fed it to the deep neural network and it would convert this leap movement into the text or audio data, and you will be able to convert this mute into audio visual, right? Then again, the most important trend in deep learning is the autonomous cars. We use the concepts of deep learning in autonomous cars, and all aspect of autonomous car can uses deep learning for different tasks, like the traffic sign detection. If you have to detect the different signs which are present in on the road, we use deep learning. For detection of the pedestrians that are on the road, we make use of deep learning algorithms. for tracking a particular object, for identifying the object, and then tracking what is the movement of the other car or the other object. We make use of deep learning concepts. Again, for identifying the proper lane, we make use of the deep learning concepts, right? So we'll again move back to, yeah. So now this model has trained itself, and in the first epoch, the accuracy is 99.14%. In the second epoch, it is 99.22%. In the third epoch, it is 99.38%. And every time you would run this model on particular uh, thing, the accuracy is going to increase, right? And the last, now we have trained our model, and now we need to check whether this model is working efficiently on our test data set or not. So the last part is to evaluate this model. First, we trained on the labeled data set. Now we'll evaluate our model on the test data set, right? So for that, what we have done, we have used the model.evaluate. The input over here is the test images and the test labels, right? Here we have put one because I want to get the first element of the matrix, which is nothing but the accuracy. The other element is the loss of the function. So I just want the accuracy of the models. I am placing it over here as one. So it would give the output of model.evaluate. It would consider all the images of the test data set and the test labels, and use this input for our model and check whether they are being identified properly or not. And based on that, it would provide an accuracy. So if I execute this, it would take few seconds. And yes, it is done. And it has detected that on the test data set, which was of size 10,000, it has produced an accuracy of 0.9865. That is nothing but 98.65%. That is around 99%. Right. So this is how we make use of deep learning models. One of the most used model is the convolutional neural network that we have studied today. And that's it from my side. So these were the references that were used to develop this presentation. These are the few references because I referred many data, but these were the few.